In this section, we are just considering the series combination of resistors. Mainly, the resistors can be combined in any circuits in two ways. One is the series combination and the other one is parallel combination. Then, in series combination means the resistors are connected end to end or just like a chain manner. One end of the resistor is connected with the other end of the another resistor. That type of a chain manner connection or combination is known as a series combination of resistors. End to end connection or chain like combination is known as the series way of combination of resistors. Then any number of resistors can be combined in this particular series manner or a chain like connection. Then what happens to the effective resistance of such a combination? That means if two or more resistors are connected in series way, then what is the resultant resistance of this particular combination? And how we can mathematically obtain an expression for the total resistance or resultant resistance in such a combination. For that purpose, we have to consider a particular series combination. Just for simplicity, we are considering a series combination of three resistors R1, R2 and R3. That means R1 is the resistance of first resistor and R2 is the resistance of second one and R3 is the resistance of third one. And these three resistors are now connected in the series manner. That means the chain like arrangement is carried out. Then in order to obtain the resultant resistance or the total resistance, we have to consider the total current and the total potential difference. So when the resistors are connected in series manner, one point you have to keep in mind is whenever the components are connected in series manner, same amount of current is flowing through each component. That means same amount of charge is flowing through this R1 and same amount of current, that same amount of charge is flowing through the R2 and through the R3. But the potential difference which is applied to that particular connection is varying across the different components. If we apply a total potential difference V, that V does not applied across R1, R2 and R3. A small portion of that potential is applied across R1, another portion of that potential is applied across the R2 and the remaining one is applied across the resistor R3. So the potential difference across the components are different, but the current flowing through each component will be the same when they are connected in series manner. In a series combination, only one path is available for the current flow. So the same current is flowing through each component when they are connected in series, and the potential difference across each component will be different. Now here I be the total current flowing through the circuit, then V1 is the potential difference across a resistor R1, V2 be the potential difference across resistor R2 and V3 be the potential difference across R3. In order to measure these potential difference, we can connect a voltmeter across these R1, R2 and R3. Then these voltmeters will indicate the voltage values as V1, V2 and V3. And in order to measure the current, if you are connected an ammeter, then that ammeter indicates the total current I in that particular circuit. Then after considering the circuit, the total potential difference applied across the circuit will be V, and that V is divided across this R1, R2 and R3. So the total potential difference we will obtain as the sum of the potential differences across R1, R2 and R3. So we can write it as the total potential difference V equal to V1 plus V2 plus V3. The total potential difference V equal to potential across R1 plus potential across R2 plus potential across R3. Then according to Ohm's law, we know that this potential difference V equal to the product of current and resistance. According to Ohm's law, we know that V equal to IR. So instead of V1, we can represent as the current into resistance. So V1 we can write as V1 equal to I1 into R1. Similarly, V2 can be expressed as I2 into R2 and V3 we can express it as I3 R3. But here in a series combination the same amount of current is flowing through each resistor. So the I1, I2 and I3 are, we can write it as only I. So V1 becomes IR1, V2 becomes IR2 and V3 becomes IR3. Therefore, total potential difference V equal to IR1 plus IR2 plus IR3. Here I is a common term and we can take it outside. So V equal to I into R1 plus R2 plus R3. Here V is the total potential applied across the circuit and I is the total current flowing through the circuit. And just taking this I to this side or throughout dividing by this total current, the equation becomes V by I equal to R1 plus R2 plus R3. Then V by I means the total potential difference divided by total current will give the total resistance. So the R effective or the total resistance of the circuit R effective equal to R1 plus R2 plus R3. This is the mathematical form of series combination of resistors. When a number of resistors are connected in series way, the effective resistance or the total resistance of the circuit becomes the sum of individual resistances, that is R effective equal to R1 plus R2 plus R3. Suppose if you are only connected two resistors, then the effective resistance or the total resistance R effective equal to R1 plus R2. And if four resistors are connected, then R effective equal to R1 plus R2 plus R3 plus R4. So the same equation can be extended up to n number of resistors. And if n number of resistors are connected in series way, then R effective equal to R1 plus R2 plus R3 plus etc. plus Rn. Then in case of the series combination, the effective resistance is the sum of individual resistances, or the total resistance is the sum of individual resistances. In a series combination, the effective resistance is always greater than any of the individual value. The total resistance of the circuit should be greater than any of the individual values in that circuit. That is, in the considered circuit, the R effective value should be greater than the value of R1 and it should be greater than the value of R2 and should be greater than the value of R3. One more point we have to consider, that is, if the n number of resistors have the same value, then the effective resistance becomes R effective equal to N into R. If n number of resistors have the same resistance value, then the total resistance of the circuit becomes Rn.